Hi everyone, and on one last problem today, I'm going to show you how to use the Pythagorean Theorem at a very, very basic level. So what I want you to do is, on your notebook paper or wherever you're taking notes, cut your page into 4 equal sections, and I want you to label the first one, Pythagorean Theorem. Make sure you know how to say this because it makes you sound smart. The other one is when you're missing a hypotenuse, which is spelled Hypotenuse. We'll talk about that in a second. And missing leg, and then by the end of this video, you're going to be able to take on a word problem. This video is not going to talk about who Pythagoras was. We're going to do that in a later video, but know that he was this man who created this influential theorem. So before we get into it, you have to understand A, what the Pythagorean theorem is, B, when you can use it, C, how you can use it. So when you are asked to use the Pythagorean theorem to solve for the missing length of a triangle, there's a few things you have to know. One, this can only be used with a right triangle. So a right triangle is noted with a little square. This tells us that it is a 90-degree measure of that angle. So I'm going to tell you that now because if the problems don't say this in the directions, you can't solve for it. So this really is a 90-degree angle whenever there's a little square denoted in the corner of the triangle. The sides of these angles are called legs. A and B in this case are referred to as legs. It could be any type of variable, but A and B is what we use when we talk about Pythagoras' theorem. Side C right here is called the hypotenuse, which I mentioned, and it's a real fancy word for the longest side of a triangle, and it's always opposite from the 90-degree angle. So I think a lot of people remember how, or what the Pythagorean theorem is because A, it makes you sound smart, B, you get to use the word hypotenuse, and C, it's a very simple theorem with a name that I think truly just makes you sound smart. I bet if you ask any adult if they remember this theorem, they might be able to rattle it off for you, but they may not know how to use it, so you can teach them this. So the most important thing that I don't have on here is the theorem itself. A squared plus B squared equals C squared. The sum of the squares of the legs will always equal the hypotenuse squared. The two very most basic problems you can find from this are finding the missing hypotenuse length or finding a missing leg. So let's start first with the missing hypotenuse. In your problem, you're going to obviously be given a triangle, and it better have stated somewhere that it has a 90-degree measure in one of the angles. If not, you can't do the problem. So if you really want to make your teacher mad and they didn't do that. So in this problem, we have 2 legs, a 5 and a 12. We don't know if it's inches, centimeters, kilometers, whatever it may be. Right now we're just going to call it units. So we have 2 legs, we have our C that is missing, and the C is usually denoted when finding the hypotenuse. So if I use this, I'm going to plug in my legs and square them. So 5 squared is 25 plus 12 squared is 144. If I add those two numbers together, 25 and 144, I get 169. And in your head, if you're good with perfect squares, you know that 169 is a perfect square. So in order to figure out what C is equal to, I have to now take the square root of both C squared and 169 to find out that C is truly equal to 13. This is actually referred to as a Pythagorean triple because all 3 numbers are whole numbers, and there are infinite amounts of Pythagorean triples, but that's for a different video. Now let's look at when you have a problem where the leg is missing. Going back to this problem, most students ask, does it matter if the 12 is the A or the B? And does it matter vice versa if the 5 is the A or the B? No, it doesn't, because as you know in addition, you can use the commutative property to move around 2 addends. I think that's the word for it if I want to sound really smart. And you will still get the same answer. So no, it does not matter which one you call A and which one you call B. Those can be flipped. Legs are A and B. The C always does matter. So let's take a look at a problem when we are missing a leg. This time we're given an A, we're missing the B, and we're given the C in this case. So if we were to set it up, I would plug in 6 for my A, so 6 squared plus B squared, I don't know what it is, equals 10 squared. So right now I know in my head 36, 6 times 6 is 36, because that's what it would be if it was squared, and 10 squared is 100. So now I have an equation, and that's what's cool about the Pythagorean Theorem. It looks like geometry, but we use algebra to find unknown values, but this is the root of many other different types of maths. So obviously it takes us into trigonometry, it takes us into physics, you know, a lot of digital rendering goes back to using triangles, like when you watch like a Pixar movie, like Toy Story or Coco or Frozen. So now that I have my equation and I subtract 36 from 100, I get 64. Oh my gosh, we found another perfect square. I'm just giving you the easier ones right now, and I'm using Pythagorean triples because I said this is going to be a basic video. So if I have to figure out what B is, I still have to take the square root of B squared to get B, and I'll also have to take the square root of 64, which is 8. In this case, whenever you take the square root, we know that both a positive and negative value can be our answer, but think to yourself, we're looking at a model of something that is represented. We can't really have a negative value for this. In other different types of maths, you may explore that there might be a negative value somewhere else, but right now, we're only going to take the positive answers. So for this missing leg, it would be 8. And if you take a look at it, we have 6, 8, and 10. Do they have a common factor? They sure do. I could divide all those numbers by 2, and I would get 3, 4, and 5, which is another famous Pythagorean triple, but we'll save that for later. Last but not least, you're not walking out of this video. I guess you could hit pause whenever you want without tackling a word problem. Just like any other word problem, you have to break it down. You have to visualize something. But all of these wonderful problems had pictures of triangles. So just thinking to yourself, what do you think you should do if you get a word problem like this? If you said do it in your head, no, you're wrong. You're going to draw a triangle. Whenever you're given a word problem with using the Pythagorean theorem, use a picture. So if I had a question that asked me something along the lines of, there's a person who has a ladder and they're trying to get to the second or third story of a house. And the length of the ladder that the person has is, this is looking a little Blue's Clues. The length of the ladder is 17 feet long. That does not look like feet. And the person places it 8 feet away from the house. How tall can that ladder reach the building? So you do have to draw some pictures in some of these instances, but the more important part is understanding, is this a problem where you're missing the hypotenuse or missing a leg? Well, the 90-degree angle would obviously have to meet here. They would have to tell you that in the problem. If they don't, we wouldn't be able to solve it with this. So, same thing. The side opposite of the 90-degree angle would obviously be the ladder of 17 feet. So if I were to do this, I want you to try it right now using the Pythagorean theorem. A squared plus b squared equals c squared. Remember, in all these problems that we've done today, we've had perfect squares when we get to that last step of getting rid of something to a second power. Keep in mind that it doesn't always have to be a whole number. You are allowed to get irrational numbers. So obviously, depending on the directions that you have, it'll tell you to round to the nearest whole number, 10th, 100th, whatever it may be. I will give you a hint with this one. You will get a whole number because this is another famous Pythagorean triple. You're welcome. I hope my way of organizing the notes for you today was a way for you to take everything in and try some practice problems on your own. More practice problems will be coming in case you need some more assistance. Please feel free to subscribe to this channel if you found it worthy of your time. Thank you.